So hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So in the last video we talked about artificial neural networks and we implemented it using TensorFlow. So in this video we are going to talk about convolutional neural networks and then we build our own CNNs using TensorFlow. So let's talk about why we need CNNs, why we can't use ANNs to deal with the image data. The main problem with ANNs is that it tries to memorize the image instead of learning the feature from the data. So in a way it does some kind of template matching. So for example, here we have a cat image. So if we build a neural network that classify the image of cats and dogs, and if the left side image is in training sample, but the image on the right hand side is not encountered during training, then we might not be able to identify the right hand side image if we test the model. And that is because this right hand side image was never encountered during training, so it never learned the template for this image. Although they are same images, it is just that the right hand side image is inverted. So to solve the problem, we have another network, that is convolutional neural network. And I have already written a blog post about it, so we will take the help of that blog post to understand this topic. And if you want to know what is template matching, I have made a video about it and the link is in the description. So let's jump to my blog. So here I am in the blog post and we are going to learn about 4 layers of convolutional neural network. So the first question that comes to mind is what is convolution? So convolution in mathematics is a way to combine two or more functions and we get some output. And this is widely used in the field of signal processing and reliability theory. And in later part of the video, we will see how we use this idea of combining two or more things to get another thing. So here is the mathematical representation of convolutions. And don't worry about the maths. We will not be going into hardcore maths. We will try to understand it using some example. And once you get the idea that's what is happening, then the math won't be that much tough for you. Now let's look at the structure of CNNs. So the first layer is the convolutional layer. Thereafter, we have detector layer, which is also known as activation layer. Then we have pooling layer, and in the end, we have fully connected layer. That is artificial neural network that we learned in the previous video. So first we feed the input to the convolution layer, then it passes to detector layer. Next, it passes through pooling layer, and then to the fully connected layer for the final predictions. So this is a very simplified version of what happens and how convolutional neural networks work. So let's dive deep into each layer of the network and understand the functionality. So first we have convolutional layer. As we know that our image can be represented by pixels. And here we use the example of grayscale image, which has width and height only. Next we have kernels or filter. It can be thought as a filter you use in camera to edit images like applying blurring filter to blur the image, etc, etc. So how convolution operation happen? So here the filter moves over the image and do some kind of calculation and output another image, or you can say a feature. To make things easier, suppose image input is your photo and the filter is blurring filter. So when you apply filter, you get the desired result as an output. And in this case, you get a blurred picture of yourself. So here idea is that with the help of two matrices, we are getting the third matrices. So hence we call it convolutional layer. So what's the mathematics behind the scene? So here we can see the formula. So every time filter moves over the image, it calculates this thing. And the operation is known as element-wise matrix multiplication. So this whole thing is also known as cross correlation because using this mathematics, we are just trying to figure out where in the image this filter most correlated. In CNNs, the resulting images are called feature. So we try to create a feature maps. So this might seem a little tough to imagine. So here what I do. So suppose the image is my face and one filter can find my nose, another filter can find my eyes and so on and so forth. So this way I will have a feature map. So this feature map will allow CNN to learn about my face. One thing to mention that the actual process is way more complicated, but this example will help you understand CNN better. And when you read any literature, you won't find any problem understanding things. And here is the example of CNN used for detecting handwritten digits. So here I draw 5 and it created 4 feature maps. So one is detecting straight line, one is detecting curve and so on and so forth. And I have provided the link of the website in my blog and I would suggest you to go and check it because this website allow you to draw numbers and then it predicts which number it is using CNNs, and the most amazing thing about it, you can visualize what is happening at each layer. Next we have detector layer, also known as activation layer. So depending on the kind of literature you are reading, you may or may not come across this layer because many people don't consider it as a separate layer. But I am going to consider it as a separate layer. So in this layer, it breaks the linearity in the data and brings non-linearity because our images are non-linear in nature and we want to maintain that. And we do this by passing the output of convolution layer to rectified linear unit. Next, we have a pooling layer. So here a square matrix is mapped over the feature to create a summary statistics for that particular region. So why we use pooling? Because this allows the model to become unaffected by small transition in the images. So this way, even if we get a tilted image of cat, we might be able to predict that. So there are two types of pooling that are widely used in CNN. That is max pooling and the average pooling. So here is the example of max pooling. So we have to decide the dimension and stride for the pooling operation. So here we have 2 by 2 matrix and stride is also 2. So whatever is the maximum in that region, we have to take it and move to the next area. So this allows us to compress the image further while retaining all the information. Next we have average pooling and it works same as max pool, but here we use average instead of maximum value. And which one works better is something you have to try. There is no hard and fast rule for this. And lastly we have our fully connected neural network. So we feed the output to neural network to get the final results. And here is the whole network visualized using the same website. So that's all from my side, and there is a lot to explore in CNN. So I would suggest you to find some good literature and follow it. So let's jump to the Google Colab and implement it using TensorFlow. So here I am in Google Colab. So I have already imported the essential libraries. Additionally, I have imported early stopping from the callbacks. And we will see how this helps us in dealing with the problem of overfitting. So let's run these cells. So first we import the CFAR10 dataset and it contains images from these 10 classes and you can find this dataset on Kaggle as well. So next we look into the class label and how it is related to our class name list. So if I call second prediction, we get this kind of structure. So here we have an array and its data type. So to grab this number, we have to index it. So let me do that. So as of now, we don't know whether it's a car or airplane. We only know that it is a ninth number. So in order to get this, whether it's an airplane or car, so to get the name of the prediction, we use this to index the class name list. So this will give the ith element of the list and this is what we have done in the next cell. So let's check the class label for this image and that is a truck. So the second image in our trained data set is of a truck. And next I have plotted these images but this time we have used the title as well. So first we define the dimension for the plot. Next, we ran a for loop. After that, using subplot functionality, we plot multiple images. Then using the same indexing, we created the title for each image in our dataset. So let's run this cell. So in the previous video, we did not have any title, but this time we have a title for each image. So this way we can create a plot where each image has a title as well. And this is the correct way to plot images. So from this plot, we can see that we have different images of the same thing. Like take the example of truck. Here we have the front and back of the truck. So we have the different orientation of the same category. And our task is to create a model that can identify them correctly. And as usual, we normalize the dataset because we know that neural network train faster on scale dataset. So let's check the shape of the dataset. So in the training dataset, we have 50,000 example and each image is 32 by 32 pixel size and 3 represents that it is a colorful image. So earlier we were dealing with the grayscale images only. So we have done all the required things. Now it's time for us to build the model. And in the previous video, we saw that model building was verbose. That is, we had to write too many words. But in this tutorial, we are going to shorten it to save some time and to avoid complexity. So to do that, we simply import all these things so that we don't have to write them again and again. So from tensorflow.keras.model, we are going to import sequential model. And the sequential model is one where output of one layer is input for another layer. Now it is time for us to import all the layers that are required to build the model. Next we import tensorflow.keras.layers and we import following layers. So first we import dense layer, that is our fully connected layer. Next we have activation layer that we talked in lecture series. Next we have con2D, that is convolution layer that will do the convolution for us. Next we use max pooling, that is max pool 2D to compress the image further. And next we import flatten layer to connect the convolutional layer to fully connected layer. And lastly, we import dropout layer. Now we don't have to write tensorflow.keras.layers every time we add a layer to the model. So let's build the CNN model. So first we are going to instantiate the model. So model is equals to sequential. Next we add the layers. So the first layer we are going to add is convolutional layer. So we simply write model.add, then we pass conv2d and it takes few parameters. So the first parameter is the input shape, which we know is 32 by 32 by 3. So you see the CNNs are capable of dealing with both grayscale and colorful image as well. So next we have to pass the number of filter or feature. So this will create a feature map and in this case we pass 64. And the last thing we have to pass is the kernel size or you can say filter shape. And in our case we are going to use a 3 by 3 kernel and that's all we have to do for the convolutional layer. Next we have to create an activation layer so that we can add non-linearity in the model and the code is going to be very simple. So we call model.add, then we pass the activation layer and then we define the activation function that is going to be ReLU. Similarly, we add max pooling layer and that will make the model invariant to the small changes in the spatial structure of the image. So we call model.add and we simply call max pool 2D. So just like artificial neural network, we can add as many as layer we want. We can do the same with convolutional layers. So I'm going to copy paste the whole code and make few changes. So first I'm going to change the input shape. We don't need this input shape now. And next we are going to change the number of filter. That is going to be 128 for this layer. So as of now, we are going to have only two convolutional layers. But later on, we will design some more complicated structure. So next we connect this layer to the dense layer and we have to first flatten out the output. So we simply add another layer that is flatten layer. So we write model.add and then we call our flatten layer. So that's all we have to do for flatten layer. Next we have to build the dense network, that is artificial neural network, and we have built one in the previous video. So we call model.add and then we pass the dense layer and then we pass number of units. So in this case I am going to pass 512. You can pass whatever number you want. Then we pass the activation function and that is going to be our ReLU function. Next I am going to add couple of layers to the model. So we are going to copy paste the same code. So let me first format it a little bit. Okay, so let's paste this cell and now we are going to change this 512 to 256. Next, we add dropout layer to save the model from overfitting. Although we will see that in later part of the video that model is going to overfit and we will also see that how to tackle this problem. And finally, we are going to add output layer. So we are going to copy paste the same code and then we make the few changes. For example, we are going to change the number of unit to 10 because we know that we have only 10 classes. And next we change the activation function to softmax function because we want to return the probabilities of those classes. Next we have to compile the model and we have done this too in the previous video. And we know that here we decide the optimizer, loss function and the metric for the model. So let's first define the optimizer and in this case we are going to use Adam optimizer. Next we have to define the loss function and in this case we are going to use sparse categorical cross entropy. And next we find the matrix on which we want to assess the model. And in this case, we are going to pass sparse categorical accuracy and make sure to pass it as a string in a list. So that's all we have to do to build our CNNs. So now let's check the model whether it built successfully or not. So here we are getting an error because I forgot to add parentheses in max pool theory. So let me do that and we will run that again. So the model has been compiled successfully. Now let's check the summary of the model. So we call model.summary. So here we can see that we have two convolutional layer and three dense layer. And in between we have activation, pooling and dropout layers. And in total we have to train 25,69,354 parameters. So next we have to train this model on trained dataset. So we call model.fit and then we pass the training image and then we pass the training labels. And then we define the validation split. So in this case, we are going to go with 0.3, that is 30% of the data is using for validation split. And next we define the number of epochs. So in this case, I am going to go with 30. And next and final, we pass the batch size and the batch size is going to be 32 this time. So let's train the model. And one thing you will notice is that it is training quite slow. And the reason because we are running it on CPU and not on GPU. So to run it on GPU, we have to change the setting. So click on add it, then click on notebook settings. And then from here you can select the GPU. Once you select the GPU, click on save. And then you will see that it start reconnecting. So wait for some time and you will have this GPU connected. So next we are going to rerun all the cells. So click on runtime and then from here we have to click on run all so that we can run all the cells. So it will take some time because it is running all the cells again and again. So here the model is training on GPU and we can see the difference. Now it is way faster than the CPU. So let me fast forward in time since model will train for 30 epochs and it will take some time. So model is done training and now it is time to visualize the losses. And I have already written the code and we have talked about this code in previous video. So first we store all the information in the loss variable using pandas data frame. Next we plot the element of these losses. So here we have graph of losses on left side and accuracy on the right side. So if we look at the losses graph, we observe that as the training goes on, our training loss kept on decreasing while the validation loss decreases for the first few epochs, but after that it start to increasing. And this is known as overfitting, where model performs quite well on training data but fails to perform on unseen data. So this way we can figure out whether model is overfitting or not. Next on the right side we have accuracy graph and here we see the same thing. Accuracy is getting better and better for the training data but for validation data it has stuck between 0.6 and 0.7. So now we have to deal with the problem of overfitting and for that we are going to use the technique known as early stopping where we stop the training on certain criteria and this criteria is set by us. So let's implement this. So we are going to use the same model and for that we just copy paste the whole code and add another line of code that will set the criteria for early stopping. So first we are going to create a early stopping variable, then we call early stopping and it takes few parameters. So the first parameter we set monitoring equals to validation loss. So this monitor model on the basis of validation loss of the model. Next we pass the mode equals to minimum. So this will monitor the model till the loss reaches minimum value. Next we pass the verbose, that is nothing but how wordy we want the information be. And last we pass the patience equals to 3, that is if the model detected loss we want it to continue for 3 more epochs. So to summarize this, it is saying that keep watching the model on validation loss and when it's minimum run 3 more epochs and stop the training. Next we have to fit the model, so I am going to copy paste the same code. Then we have to make a little change, that is we have to pass the early stopping variable. So now we have to pass another parameter that is called callbacks. And then we pass our early stopping variable as a list. So to summarize all these steps, so first we created the model, then we defined the parameters for early stopping, and then we are going to train the model based on early stopping. So let's shift enter and run this cell. So model has started the training. So as usual, I'm going to fast forward in time. So here we see that model stopped the training at 7th epoch. So it detected the validation loss was minimum at fourth epoch. And from there it trained for three epochs and then stopped the training. So this way we can make use of early stopping. Next we are going to save the model history into loss variable. So we copy paste the code. Next, we also copy paste the visualization code as well, and we will see that how it looks like on graph. So here we see that the loss was decreasing, but suddenly it increased, and we stopped the training. So it is always better to have a model that has less accuracy than a overfitted model. Next, we are going to use classification report to see for which class model performed best and worst. So first we save the prediction of the model. So prediction is equals to np.argmax, and then we pass the model.predict, and inside it we pass the test set. Next we give another argument for np.argmax, that is x is equals to 1. Next we import classification report from the sklearn module, and this will allow to look at how is model performing for each of the classes. Next we print the classification report. So we have to pass two things. First we pass the actual values, and then we pass the predictions. So here we have the classification report, but the problem is that we don't know the class because 0, 1, 2, 3 does not make any sense. And to deal with this problem, we have another thing. So in classification report, we pass another parameter, that is target names. And in this case, we pass the class name that we have created earlier. So now we can see that clearly that for which class it performs well and for which class it performs worst. And the last thing I want you to show that how we can pass these correct and incorrect class labels as a title and visualize it. And the code is very similar, so I am going to directly show you. So here is the code. So let's run this cell and see the visualization. So now here we can see that in title we have prediction class and original class. For example, in this cat class, the prediction class is cat and original class is also cat. But for this image, the prediction class is deer and the original class is frog. So this way we can visualize the data. So that's all for this video. And if you haven't subscribed my YouTube channel, please do like and subscribe and press the bell icon for the future update. So see you in the next video. Till then, bye, stay safe, wear mask.